All right, covalent nomenclature is really different than ionic nomenclature. And just a reminder, when we were naming ionic compounds, we followed this process where we would identify what cation was being used and we would name it. And we would identify which anion was being used and we would name it. And then we would just put the two together, okay? And we wouldn't say, unless it was a transition metal, we would never have to say anything about the charge because they were defined. And never at any time would we ever say how many of each cations and anions we had, because that was defined by the relative charges, because we have to have a total charge of 0. Okay, so it's a little bit of a process to name ionic compounds. In comparison, covalent compounds are really interesting because it turns out there are many different ways that I can share electrons, and I can end up with molecules which have the same elements, but I have two different molecules. So for instance, we have already seen that there can be a valid molecule with this structure and a valid molecule with this structure. So I can't ever say I've got a molecule with carbon and oxygen, and you could just know how many of each there would be, unlike ionic compounds, right? If I'm making an ionic compound between, say, sodium and chlorine, knowing what I know about ions, that this is always a +1, this is always a -1, there's only one molecule I can make, and it's going to be NaCl, one of each. I can't ever have two sodiums and one chlorine. I can't ever have one sodium and two chlorines. It's always 1 and 1. But if I'm saying I'm doing a covalent bond between carbon and oxygen, well now, okay, all bets are off. I can't just predict that. So when we name these, what we're going to do is we're going to name the first atom listed, and we're going to name the second atom listed, kind of like we did for ionic compounds. And we're going to change the suffix of the second one to "ide," just like we did in ionic compounds. And the difference is here we're just going to tell you how many of each that there are. Okay, 2 is di, and this is Greek prefixes, most of which you will have to memorize, but most of which you actually are already familiar with. Okay, and here they are, they're in your lecture notes. 1 is mono, 2 is di, 3 is tri, like a triangle, 4 is tetra, like your tetrahedral, 5 is penta, like a pentagon, 6 is hexa, like a hexagon. You guys are totally already familiar with these Greek prefixes, and that's what you're going to use. And there's only one exception, and that is if it's the first atom listed and there's only one, we don't use mono. So no mono if it's the first atom. And following those rules, then, this has 1 carbon and 2 oxygens, but the carbon comes first, so we don't use mono. Therefore, this is carbon, because I've got 1 carbon, and then I have 2 oxygens, so that makes it dioxide. And this molecule has 1 carbon. We don't use the mono because it's listed first. And then only 1 oxygen, so we are going to use the mono. And I'm going to drop the O because it would be weird to be like monoxide, like I've got too many O's together. I'm just going to call it monoxide. Carbon monoxide. So that's the difference between carbon dioxide and carbon monoxide, and that's how we get to those. So this is actually a lot easier than ionic nomenclature because I'm just telling you how many of each there are, so it's really easy to put it together. Or if you're looking at the formula and coming up with a name, you tell me how many of each there were. Okay, so we'll do a couple examples here, then we'll look at the in-class activity sheet, but I think that you guys will find that this is the funnest thing you've ever done in this class. Well, I don't know about fun, but this is relatively easy, and that makes it a little bit more fun. All right, so if I have 1 sulfur and 2 oxygen atoms, how would you guys name that? Sulfur dioxide. Sulfur's listed first. There's only 1, but since it's first, we don't put mono. 2 oxygens, so that's a dioxide. Excellent. PF3. Any votes? Caleb's got a vote. I'm waiting to see if Diana and Katie agree with him. Katie agrees. Diana agrees. Perfect. So it's got phosphorus, and then it has three fluorines, so that makes it trifluoride. Okay, no space between the tri and fluoride. Excellent. Okay, oxygen difluoride. Can you guess what that formula is going to be? OF2. Well, Susan Newland, that's right. If we were looking at ionic compounds, for covalent compounds, the second one always ends in "ide." We'll never see any of the others. Like in ionic compounds, sometimes they ended in "ate" and "ide" if it was polyatomic, but since we don't have any of those here, we just name the second atom and end it in "ide." Okay, and carbon dioxide, ooh, we already did that one up here. Carbon, 2 oxygens. Are you guys feeling like that's kind of straightforward? Are you waiting for the other shoe to drop? It's got to get harder. Yeah. Okay, what if it's, let's see, N2O4, I think it's here, right? We've got that. Okay, so section 5 in class activity sheet. We've got lots of fun examples, including something like N2O4. Let's just go through these. Let's see how many of these we can name at section 5, and then section 6, if I give you the name, can you give me the formula? Actually, let's do section 6, because it seems like it might be a little bit easier. You guys tell me, what would phosphorus triiodide look like? Okay, yes. 1 phosphorus and 3 iodines, Pi3. Yep. Okay, we just did carbon monoxide in the other page. 1 carbon, 1 oxygen, carbon monoxide. Sulfur dioxide? Tell me what that one should be. SO2. What about sulfur hexabromide? Ooh. Sounds fancy. Hexa. Like a hexagon. Excellent. 6 of those. Yep. Okay. Bromine trifluoride. BRF3. Excellent. Boron trihydride. Oh. Am I going to trip you up? Nope, not tripped up. BH3. Oxygen dichloride. Dichloride. Yes. OCLT. That's what you meant. That's what you meant. Okay. Nitrogen tribromide. I can put one like this on the test, right? Nitrogen disulfide. Oh, you guys are pros. Okay. Each of these only had 1 of the first atom listed, but what if we have like 2? Help me out. Go backwards with me. How might you guys name this guy? Now I have nitrogen, so nitrogen. And now I have oxygen, so that becomes oxide. Now I just need to say how many of each I have. Yeah, close. Put the di in the front, so dinitrogen. And then because I have 2 of them, and then I have 4 oxygen, so that becomes tetra. Tet. And I'm going to drop the A so it's not like tetraoxide, and I have this weird double vowel thing in the middle. Perfect. Dinitrogen tetroxide. I'm just telling you, there's 2 nitrogens and 4 oxygens. That's important because holy cow, look at how many different combinations I can make between nitrogen and oxygen. I tell you, you have a covalent compound between nitrogen and oxygen, you have no idea which one of those I'm talking about, unless I tell you it's dinitrogen tetroxide, for instance. Or how would I name this guy? Jay Houston's got it. You have to tell me that there's only 1 oxygen. It would be mononitrogen monoxide, except that we never say mono if it's the first one listed. So it's just nitrogen space monoxide. Okay, what about this next guy? You guys weren't entirely wrong, you just weren't completely right. Don't know if that makes you feel better. Nitrogen dioxide, excellent. What about this third one? Got 2 nitrogen, so this will be dinitrogen. And then 1 oxygen, so it's got to be monoxide. Excellent. Okay, CO2 is our example on the other page, so you guys should have this one. What's that? Carbon dioxide. Once upon a time, I found a really funny ad for like Ace Hardware where they were selling carbon monoxide detectors, which are really important, except that it said CO2, like it was a CO2 detector, even though it was a carbon monoxide detector. It was like, I can't be the only person in the world to know that those aren't the same thing, but I guess not everybody really stops and looks and pays close attention to that, but I should have saved it, scanned it in, put it on the discussion boards for you. CO2, not the same as CO. Carbon monoxide will kill you quickly. Carbon dioxide, if you get enough of it that it displaces the oxygen, then it'll kill you, but it's a little bit different mode of action. Carbon monoxide binds to your hemoglobin so that your hemoglobin can't carry oxygen anymore. So it's a poison, whereas carbon dioxide just takes up space. That's all. Okay, tangent. Woo. SiCl4, how would you name that? Silicon tetrachloride. Nicely done. 1 silicon, 4 chlorines. Do you guys feel good about these? Do you want me to keep going? I mean, it's kind of fun. Yes, you feel good, or yes, you want me to keep going? Crap, I shouldn't ask questions like that, should I? We feel good, okay. All right, so you guys are waiting for the other shoe to drop, right? Because it's never this easy, is it? It's never this easy. Okay, here is the extent to which the other shoe will drop. This is the extent to which it gets harder. On the exam, when I ask you to name a molecule, I might not tell you if it's an ionic or a covalent compound. And they have different naming rules. So if I ask you to name something, before you do anything else, you should be able to tell me if it's ionic or covalent so that you can then continue on to make sure that you use the right naming rules to name the molecule correctly. Does that make sense? You with me here? Ionics are different than covalents. So if I ask you to name something, step 1, you're going to have to ask yourself, is it ionic or is it covalent? So that is what section 7 is about. Just a friendly reminder. Now that we've covered covalent compounds in general, and now that we've covered ionic compounds in general, let's see if you guys can tell me which is which, right? And before I ask you this question, let me ask you guys, how would you know? Janica, well, it is. It is 4 or 5, and it is 3, 4. It depends on which book you have. If you have the 6th edition or previous, then it's on chapters 4 and 5. And if you have the 7th edition, then it's on chapters 3 and 4, because the 7th edition chapter 3 is the 6th edition chapter 4, and et cetera, right? So the better answer is that our test is on ionic compounds and covalent compounds. And whatever 2 chapters in your book cover ionic compounds and covalent compounds, that's what's on the test. I'm sorry, I hope it's not super confusing to you guys, but yeah, whatever. I think the 7th edition, it's chapters 3 and 4, isn't it? It wasn't meant to be confusing to you guys. Just, if you're following along in the same chapters that I'm at, then you'll for sure have the right stuff. And if you're following what's listed in the concept study guide, regardless of what chapter it says that it is, then you know you'll have the right stuff. So, yeah, no problem. Okay. All right. So the question was, do I know if it's ionic or covalent? You say, do all the steps, look at electronegativity. That's the long and drawn out way to do it, based on our differences in our electronegativity table, right? Like, refer, does it belong in this section versus does it belong in this section? There's a shorter way to do it for the purposes of this class. No problem, Jenica. One shorter way to do it, and this is what I want you to know for the purposes of this class, because there are some exceptions, because this is, it's a spectrum, but for the purposes of this class, if I have a metal and it's bound to a nonmetal, then I'm going to call it ionic. And if I have 2 or more nonmetals, then it's going to be covalent. Is that fair? Pretty fair? When these guys bond together, they're going to share electrons. If one of these guys attaches to one of these guys, they're going to trade electrons. That's going to make it easy, okay? The only other thing that I would watch out for is that if I have like 2 polyatomic ions, this is one reason you have to memorize them, because I want you to be able to recognize them. Because if you've got 2 different polyatomic ions bound together, that would also be ionic for obvious reasons. Speaking of which, you guys have those all memorized, right? Okay, you're getting there. Okay, so section 7, you tell me, LiCl, ionic or covalent? Ionic, why? Lithium's a metal. Second I know I've got a metal, then I know it's going to be ionic. Excellent. CH3Cl, ionic or covalent? Covalent. All nonmetals. Don't see any polyatomic ion. Looks good. Na3N, ionic or covalent? Ionic, why? Because sodium is a metal. Ionic. Perfect. PBr3, ionic or covalent? Covalent. NH4NO3, ionic or covalent? One vote for ionic. Anybody else? Can anybody second that motion? Do I hear any dissenting votes? Nobody's brave enough to say one way or another. Oh, here we go. Megan agrees. Caleb disagrees. All right, explain yourselves, people. Why ionic? Perfect. I've got two polyatomic ions. I've got an ammonium ion and a nitrate ion. So this is an ionic compound. Excellent. Okay. SOCl2, ionic or covalent? Covalent? Guess what, we keep going? Or do you feel like you got this? With the correct answer either being, quote, keep going, or quote, I got this. Because if you say yes, then I don't know. We're good to go. Okay, we got this. All right, so now we're going to take this and apply it to part 8. We're going to name this stuff. But before we name it, we have to know if it's ionic, because that takes different naming rules, or if it's covalent, because that takes the naming rules that we just covered. Okay? So LiCl, we already said that was ionic. So according to the ionic naming rules, how should I name this molecule? Lithium chloride. Perfect. These are both main group. So it's just the name of the cation and the name of the anion with an IBE. Okay, CCl4, ionic or covalent? Covalent. So according to my covalent naming rules, this molecule should be called what? Carbon tetrachloride. Excellent, because I've got 1 carbon and 4 chlorines. Excellent. Na3N, ionic or covalent? Ionic. And we're going to name it what? Sodium nitride. Both main group. Okay. PBr3, ionic or covalent? Covalent. So the name of that's going to be what? Perfect. Phosphorus tribromide. Bromide. I should be typing these instead of writing them to be clearer. Phosphorus tribromide. Look at the spelling given by J. Houston and Diana, because they are right, and you can, it's the same thing here, but it's hard to see. All right, NH4NO3, we decided it was ionic. According to our ionic nomenclature rules, how are we going to name that thing? Perfect. The name of the cation, polyatomic ion you memorized. Ammonium, the name of the anion, polyatomic ion you memorized. Nitrate, ammonium nitrate. Excellent. Let's skip down to this one. CuO, ionic or covalent? Ionic with a question mark. Anybody else wants? Robin agrees. Ionic. Why ionic? Because Cu is a metal. Okay. Excellent. How would I name that according to our ionic nomenclature rules? Cu is copper. Okay. Oh, Jay Houston nailed it. Jenica and Robin were very close, but they got that question wrong on the test. That's okay. This is an imaginary test, which isn't worth any points. As long as you get the question right on the test on Wednesday, then you'll be great, right? Why do I need that too in Roman numerals? Because it's a transitional metal. You have to tell me what that is. Now, how did you come up with the 2? Where did you get that from? We looked at the charge on the oxygen, which was -2. That told you what the charge on the copper had to be, which is +2. And it's the charge that goes in the parentheses. So that's why it's copper 2 oxide. Excellent. Don't forget those rules. Okay. Rules for ionic compounds with transition metals are different than rules for ionic compounds with main group metals. And the really common questions to miss on the exam are knowing or using the Roman numerals or using the correct Roman numerals. Okay. I am going to leave you guys to do these other 9. So I think that it's good practice for the exam. And that is it for today. Any questions?